Good morning, friends. My name is Balram Tamrakar, Assistant Professor, EC Department, KIET Ghaziabad. Today, we will discuss about the board plot concept. So, let us consider this slide, which is based on the book. So, basically, the board plot is a logarithmic plot, and it is used to find out the stability criteria of the control system. Clear? Board plot basically a combination of two different plots. First one is the magnitude versus frequency, and second is the phase angle versus frequency. So combined two graphs will known as the board plot, and it is used to find out the stability criteria in a control system engineering. So comes with the basic concept about the board plot. So we have considered a 7.18.1, that is the board plot, that is also known as the logarithmic plot for the transfer function. Look at equation number 7.47, that is the open loop transfer function. It's a generalized equation for the open loop transfer function, and it can be expressed by k into 1 plus st1 into 1 plus st2 and so on up to omega n square divided s raised to power n into 1 plus sta 1 plus stb and so on s square plus twice zeta omega n into s plus omega n square. Here k is again t1 t2 and so on, these are that are the considered as a zeros, and here in the bottom one, that is in the denominator portion, ta tv and so on, these are the poles. This concept also read in the time response analysis, where the zeta is the damping ratio, okay, omega n is the undamped natural frequency of oscillations. Clear? And comes with the this factor, which is the s raised to power n indicated the type of the system. That means if capital N is 0, then it will be the 0 type system. If capital N is equal to 1, then it will be type 1 system. If capital N is equal to 2, then it will be type 2 system and so on. So this factor is very important, this one. Yes, s raised to power n, because it indicate the type of system and also clear the nature of the response in the magnitude plot. Because suppose capital N is 0, so it will be 0 type system. So the slope will be a 0 decibel per decade. Why I'm saying per decade, I will explain later. Suppose capital N is 1, so it will be type 1 system, and the initial slope of the magnitude plot will be minus 20 decibel per decade. If capital N is equal to 2, so it will be minus 40 dB per decade and so on. So next slides we will discuss about the type of the system and also the slope for the system in the magnitude plot. Now how we can obtain this equation 7.48? Simply put s equal to j omega in the above equation, then we will find out this one. Now after that we have to find out the magnitude and phase by the use of 7.48 equation. So comes with the next, because it's a logarithmic scale, okay. In the board plot, all curve just like a board magnitude plot and phase plot, we will draw in a semi log paper. So the scale is logarithmic scale, so we are taking a natural sorry, that is a log base 10. So in magnitude we are taking, so it will be a 20 log base 10 mod of g j omega h omega. So we will find out the magnitude. So the numerator portion having, so it will be 20 log k plus 20 log mod of 1 plus j omega t1 plus and so on. These are all numerator portion and so on. Now comes with the denominator portion. So denominator portion will be minus. So it will be, first term is the minus 20 log base 10 mod of j omega raised to power n. So it will be computed as minus 20 n log omega. Next, minus 20 log 1 plus j omega ta. These are the taking a modulus. So the next portion, if we will find out, so it will be under root 1 plus omega square ty square minus 20 n log omega minus 20 log under root 1 plus omega square ta square and so on, like this one. So we have to find out 7.49 equation. Now after that comes with the angle, phase angle. It can be find out tan inverse y upon x. So it will be tan inverse omega t1, tan inverse omega t2. All these numerator portion will be plus and denominator portion will be negative. So we have find out the two terms, magnitude and phase. Clear? Now uh, we have to describe how we can draw the Bode plot in terms of constant term, in terms of numerator terms, in terms of denominator terms. So step by step we can find out. So comes with the equation number 7.51, that is the gain. The magnitude in decibel in terms of k is given by this relation 20 log k. Here also the two cases. If suppose k is greater than 1, so the values will always be positive. Suppose capital K is the 10, so it will be 20 log 10, so it will be find out the numeric value is plus 20. So the height will be from 0 decibel line, it will be 20 plus 20, just like this one, 20 log k. Suppose k is greater than 1, so always values we will find positive. Suppose k is less than 1, suppose it's a 10 raised to power minus 1, that is a 0.1. Okay, so it will be minus 20. So the graph will shown below 0 decibel, it will be minus 20. The second graph B indicated the phase angle because it having only the constant term. So tan inverse y upon x, so y is the 0, so total phase will be 0. So this line indicated a 0 degree angle. Clear? That is the plot for the magnitude plot and phase plot for the constant term, which is the k. Now comes with the next term also, that is the we have to find out the graph for the term 1 upon j omega n. 1 upon j omega n. So we have to find out the magnitude. It will be like this 120 log 1 upon j omega raised to power n modulus, so it will be minus 20 n log omega, and the angle will be minus 90 n. Clear? Now comes with the basic concept about how we can take a reference line or reference slope in a broad plot. So look in this diagram in which the magnitude versus omega and phase angle versus omega. So comes with the first diagram. See the y-axis. This is the divided into 20 decibel, 40 decibel, and 60 decibel. And in the logarithmic scale, that is the x-axis is indicated a log omega basically. So we are taking because it's a logarithmic scale. So when we are drawing in a semi-log paper, then it will be in a form of decades. Decade, that means first point is 0.1. We are not considering 0 because omega, if I'm taking 0, then log 0 is not exist. So we always we have to take a 0.1. So first is the 0.1. Good. Now next is the 1, that is the 10 times of 0.1. Now comes with the 10, that is the 10 times of 1. Again 10 times, it will be 100. Again 10 times 1000. That is the portion showing decade in the form of decade. That's why the unit is magnitude plot in, that is a minus 20 decibel per d. Per d is indicated decade. So comes with the this diagram which is indicated the reference slope. How we can find out the reference slope? So first height is the 20 decibel and the base is 0.121, that is the 1 unit. So the angle will be height upon base, that is the 20 plus 20 plus 20 I am saying. So it will be increased from this one, but is minus 20 because decaying, that's why it's minus 20 decibel. You have to know about the concept is that due to pole always a negative slope and due to zeros always a positive slope. Suppose there is only one pole and type system is 1, so the slope will always minus 20 decibel per decade. If type system is 2, then slope is always minus 40 dB per decade. If type system is 3, then slope will always be minus 60 decibel per decade. Now I'm saying about the in a reference slope. So that is the height 20 decibel, and the unit x in the base axis is 0.121, that is the 1 unit. Okay, so it will be 20 minus 20 decibel per decade. If height is 40 and the base is the again 1 unit, so it will be minus 40 decibel per decade. Next is minus 60 per dB per decade, and so on, as indicated in this diagram. Capital N is equal to 1, that is the type 1 system, so minus 20. Type 2 system, so minus 40. Type 3 system, so minus 60. Now comes with the phase angle. Now reference is the 0 degree for constant term. Now if capital N is equal to 1, the first one, which is the capital N is equal to 0, so it will be 0 degree. That is a constant, or you can say that the parallel line to the 0 at the dB axis. Okay. Now if capital N is equal to 1, so it minus 90 degree. How we can find out minus 90? Suppose in this equation capital N is equal to 1, so we are getting minus 90 degree. Okay, if capital N is 2, so minus 180 degree, and so on. This one minus 180, minus 270, and so on. So this is the total basic concept, how we can draw the Bode plot, and how we can assume the initial slope or reference slope in a Bode plot for magnitude and for the phase angle. So that is the completely known as the Bode plot for the term 1 upon j omega raised to power n.